Reverse engineering is finding the needle in the haystack. This is particularly true for this sample here. Once you know how to analyze it, so once you watch the video, it's actually not that hard to do. However, figuring out what to do, that can be hard for this sample. So if you are currently training, my suggestion is to stop watching this video, download the sample from the video description below, and first try yourself to analyze it. And then come back here for the solution. I also want to mention we have now a Discord server for malware analysis for hedgehogs. So if you're looking for some community for discussing analysis and analysis problems, sharing some links to your articles that you maybe wrote, do that on our Discord server. You're welcome to join. The link is in the description section below. Today we will be analyzing this NordVPN setup.exe file. Let me first change the extension, because as long as I'm statically analyzing this, I don't want to execute it by double-clicking it. Alright, so let me first check this with detected easy. This file is, if you check this, it's a little bit big. It's like almost 50 megabytes, but this is quite typical for setup files. However, it doesn't identify a specific setup install system like InnoSetup or nullsoft. Instead, we have just generic C++ code that is being detected. Let me check this with Portex Analyzer as well. Just to see what this might contain. It says there's an embedded executable in the resources, right? Which seems to be here, RC data resource. And we can see it right here, starts the embedded file. And if we check the visualization, we see in the overlay, there's a lot of data. So, okay. The debug path tells me actually what it is. It says here it's a single file host, and this kind of debug path is typical for .NET Core bundles. So this file here packs the whole .NET Core execution environment into the overlay, and the actual files packed inside of this. So the right tool for this job is ILSpy, not the NSpy. The NSpy, as far as I know, cannot handle this yet. So let's open this in ILSpy. And now you can see here all of the entries, right? These are a lot of entries. The first one right above here says NordVPN setup and runtime config JSON. So this is the one that's interesting. We want to check this, because like when you are not used to this, you might be overwhelmed. What should I actually analyze here? Well, you ignore all of the libraries. And one indicator is that the file that you want to look at has the file name of your original file. Here it's NordVPN setup. And the other indicator is that you have JSON files for this particular file. So this is the main file in that case. So let's look at this. And it says pyin program.main. Okay. Now we have here a initialize function that only seems to be related to graphical user interface stuff. And there's something called capture form. So we open this. We see here is a success URL for capclap.online, and it navigates to this URL. Let's actually open the whole class. See, okay. This is just that's not the class, this is the class. Okay. So that does this, but it's also calling the run, is it web browser? Okay, now I see. So this will use this function here on web browser navigated, which is then called within this navigate function, I guess. So this is a library function. You can see on the left side, by the way, where you are. So if you are suddenly in a library function, it's probably nothing you want to analyze. You can just look up the function and what it does on the documentation. So let's go back here. We see here this on web browser navigated, and it checks if there is a success URL string, and it says hide just sets visible to false. Okay, so, and then it does await run, and await run is this particular function here. So let's check this. Here's the task. Download the file from this download link. Let's click this, and this is the original NordVPN installer. So far, this application seems legitimate, right? Except for this captcha. But let's look further. Because something else we should probably do is save. Can we extract this? Yeah, I think that was the right one. So we can extract this DLL to the desktop. And now that we have this DLL, let's run the strings, because this will give us an overview of what this file might be capable of, and it doesn't seem to be obfuscated that much. So it seems like a good idea to do that. Well, we see some familiar strings here. This is the download for NordVPN, original one. But here's also another one that looks very interesting, microservicefeeder1.com, and this weird file name. That's really odd. But that's it. Nothing else that seems interesting, only this very weird file name, microservice feeder. Okay. Where were we actually? We were here, I guess. So this web client downloads this NordVPN setup. What else is it doing? It runs the setup from the download path, and then it calls installer.run. So let's go there. And here it begins to be interesting, actually, because why would NordVPN setup run an Edge update service task? So this is a task that generates the name Edge update service new GUID. Why is this suspicious? Because it's not VPN setup and it doesn't have to do anything with updating Edge. So first it deletes this task, because in case it's already there, it just creates a new one. And here it defines a trigger, and that is a ciphertext that is used for the execution of the task. So exec action is the action that is done by the task once it is started. It unloads this string. So unload strings, probably decrypting the string here. And then it uses the settings for update task. When you check those settings, then you can see this is the target URL that we've seen before. But what is unload string doing? It's decrypting the string. We have a cipher with a key and an IV. Let's click on this. So the key is simply the numbers from 1 to 32 put into an array. That's it. And the IV, numbers from 1 to 16 put into an array. Now that sounds quite easy. Let's decode this with binary refinery. Wait, that's not what I was trying to do. Let me put this on one line. Okay. I'm gonna make this a little bit bigger. So I think I can just do pack, right? Should work. To put this into, yeah. And now we want to say AES, and the IV is and the key this should be the key, just the numbers from 1 to 32, but in hex. And let's see what this does. And I think I specified something wrong. There is, oh yeah, missing. Let's make sure we use the right mode. CBC. Oh yeah. Now it's right. Okay. So mshda.exe, that's our string. And it will be decoding this string and then register this task definition here with this trigger, which is time-based. And the task is that it executes MS8, that it executes mshda on this file here. So we gotta download that. Now, I sometimes get the question how to download files like that. In my opinion, the best way to do that from home, so if you work for an antivirus vendor, for instance, you got a separate DSL line where you can do all kinds of stuff. The problem is when you do this from your home network, you actually risk infection, firstly, of your network, and secondly, you risk that your ISP might make troubles with you because you run malware. Use something like a sandbox instead, automatic sandbox system where you can run the malware and then download the file, or you can enter the URL there, for instance, and you run VMRay, anything that works for you. From home, that's the best solution. So I grabbed this file. Let's look at the rest of this here. There's something else that I noticed when you check this. There's an assembly which is encoded in here. So this might be interesting as well. Let me check the unload section. There is another decoding with the very same key and IV. So we can easily also decode this and check it out. I haven't seen this assembly being used in the file though, but let's still check it. Already got everything we need. I will be putting this into a file though. Let's remove white space. And then let's save this as as this. And now instead of using this, we will say assembly txt and then check if that gets us some sort of payload. And it does. So let's dump this assembly. And also check it here. So, okay, it's time to create a strings listing before we do anything else. We see here some mentions of browsers. We see browser processes and a link to Firefox Portable, network proxy, mentions of proxy. And it seems to set a proxy server with a specific user agent here. It waits for a while, then it checks if the process is running as an admin, and it will add a certificate that it gets from the resources here. And then it will process all of these shortcuts for these browsers. That's interesting. Chrome modifier. You see here, this is the Chrome modifier. It has a few desktop paths. It's just a struct that contains all of the names and then the paths for Internet Explorer, among others. And what it does is it modifies the shortcuts. So it searches for LNK files, and it will change them by adding a user agent. So it compares them to the exe files. So if it's a shortcut for one of these browsers or exe files that we have seen, then it creates a new shortcut and adds an argument, user agent. Text is generate user agent. So here it generates the user agent depending on the file path. Then it saves the shortcut. Is this all? It's not setting the proxy? Gecko user agent. Okay, modify press.js. Yeah, so this is part of the settings file for Chromium browsers. So they have JSON files, and it seems to set a network proxy here. When you check the settings, that's the proxy. And that's related to 752net.com. We can see here a few of the communicating files that are probably, so we can't see how they look like, but here we see that command line arguments, proxy server, you see our proxy URL and the user agent. So somewhere it probably also modifies the LNK to add the proxy. So the more interesting part is the HTA file. So let's take a look at this. Only a short one though, because maybe we analyze this more in depth in the next video. So here's the HTA file. Let me open this. So, and we can see now this is obfuscated, right? I know this obfuscator that looks like obfuscator IO for me. And let's just use a JavaScript deobfuscator like relative IM, and then put this in here and see what we get. Now it says syntax error. That's because we have the HTA header here. I'm going to remove that from the start and from the end, like so. And then we press deobfuscate, and now it's finished. So let's copy this and save it. And now we have another HTA file here. And that's interesting. We can already see there's another reference to this microservice feeder. And we see here is an index. It iterates from 10 to 0. Appends this to the microservice feeder URL. Let's replace this with URL. And that's the index, right? And I'm guessing it connects here and then checks if the connection was a success. And if that's the case, it does something here, which is, well, sending a lot of information to this URL via the post request. So this is quite interesting. Feel free to analyze this more. I executed this in a sandbox and I got another payload, another Go binary. But anyways, what I wanted to show you here is the how to deal with these net core binaries, how to recognize them. So, and how to navigate them within those binaries to find the relevant code. We have already gathered enough information to know that this is malicious. And in most cases, that's fine. So you probably, if you work for an antivirus vendor and your goal is to determine is this file malicious or clean, then we have done our job here. If you want to brush up your malware analysis skills, check out my new malware analysis course on malware analysis for hedgehogslearnworld.com. There is an intermediate to expert course. It's ideal if you're already familiar with analyzing malware, and there will soon also be a beginner's course available.